Welcome to the world of Quadri. Quadri is an information-rich common data environment for GIS and BIM data. It's providing an object, network, and process-oriented model platform for infrastructure projects, supporting all phases and disciplines involved. Applications from different vendors can collaborate by continuously sharing models in a multi-user BIM environment. All changes are tracked on person, object, and task level. This secures a consistent and information-rich model where it's easy to harvest constructible data in open formats for a fully model-based design and construction process. In this webinar, we'll go through how Quadri can be used to allow efficient, iterative design between our civil design software solution, NovaPoint, and Tekla structures using the Bridge Creator, along with some tips and tricks along the way. To give you a better understanding of what we'll go through, let's focus on this triangle for a moment. We'll start off in the bottom left with road design. This could be using any authoring tool such as Civil 3D, Open Roads, or our own tool NovaPoint, and bringing it into Quadri, which is the open common data environment platform for continuous sharing of integrated design models, and it'll enable communication of information between all your stakeholders, both man and machine, through the entire lifecycle of your project. We'll be focusing on Quadri today. And then we have the strong connections with bridge design. Now, in our case, we'll be using bridge design in Tekla structures, but if you're using other authoring tools as well, you'll be able to use other connectors, such as the Revit connector, or a simple file format, such as IFC. So Tekla structures is where you'd hold your bridge information in this case. But using Tekla structures as your main tool for bridge modeling, you can deliver a high level of detailed models, say a level of detail 350 plus. This means that you can and you should model everything if you are serious in taking all the advantages of designing with BIM. And then you've got connecting to site. You've got Trimble Connect. This is an open collaboration tool for all project participants, and it closely connects with Quadri. Trimble Connect is effectively the interface to the outside world, connecting to further downstream applications such as surveying or machine control, as well as augmented reality solutions, which I'm sure you've all seen. Then bringing it back into Quadri allows you to have a seamless integration between all three of these pieces of software. And if you combine that with Grasshopper as well, it gives you really powerful workflows that will enhance your iterative design processes and improve all modeling works. Note that Rhino Grasshopper also connects directly with Quadri. Now let's actually get into it. Now we're in the Quadri client. I'm assuming that many of you may not have seen Quadri before, so I'll take you through some simple things first. On the left-hand side, we've got a Task Explorer. We call everything a task in Quadri because it's got an input, it's got a process, and then it's got an output. So for example, if I go to some of my import tasks, we can see that I've imported some survey data. And we call it an import task because it has an input, it has a process, and then it has an output. So in the case of this import task, the input was the actual file itself. The process was some conversion rules to convert it from the native file format into a Quadri feature. And then the output is what we see on the screen right now. It's a bunch of break lines and points that can be used for ground surface modeling. Now this is just one case for the DWG. We support plenty of file types and many connectors as well. Currently, I've got a presentation window open. And if I start turning things on in my panel, we can see what we've got in front of me. So I'll start by turning on some terrain models and trees and press apply. Now if I zoom out a little bit, you can see that I've got some architectural features as well as some terrain. If I turn on drainage and apply, we can see I've got my drainage models. And if I start going through the others, such as my road and my railway, we can see how these all come together, all these different disciplines, to congregate into one model. Now if I simply turn everything on, press apply, and we can see everything that we've got in our model. And now I can even help with an ortho photo for my existing terrain. And now we can see that we not only have existing data with buildings and ground surfaces, but we also have designed data. We can even work with point clouds. If I simply drag and drop that into view like so, and zoom in, we can see the point cloud that we have there as well. Now that we've got this view open, let's go ahead and have a look at one of the bridges that we have in here already. So this bridge was in fact done in Tekla Structures using the Bridge Creator tool, like I'll show you today. And if I go ahead and select on one of my objects in this, a bridge part, we can see in the bottom left I've got a properties panel. Now this shows me all the properties that are within that object. Now Quadri is object or feature based rather than everything being file based. So if I look in the bottom right of my screen down here, I've got 95,000 different objects in my model. These are not segregated by what file they're in, but they are all now objects in one Quadri model with attributes and properties associated to them. So for example, that bridge part I've just selected, if I look down here, you can see it's got a concrete material, C50/60. It's got a class, as well as the name edge beam. Now you can customize those as much as you like. So whatever projects you're working on, you can add in your custom property sets, as we all know clients love them. Now if we look between our two roundabouts, we'll notice we have a road going through it, and a distinct lack of bridge. So this is where I'll put the bridge from Tekla Structures to show you today. The first thing I need to do is get my string lines from my road over to Tekla Structures. And I can do this by using one of the Quadri connectors that I spoke about earlier. So the way that I'll start is by creating myself a task. So I'll go into my process tree and look for the appropriate place to put it. I've already got a task called data to Tekla Structures, so I'll put it in there. Go to connectors at the top, select design, and choose my Tekla Structures template. We can see some of the other connectors that we've got on here as well. And I'll change my name to Road 501, which is the name of this main road. String lines to TS. And now I need to choose my calculation basis. Now the calculation basis in Quadri is effectively what you're selecting to be used in the task. So in my case, if I click it, I'll bring up something called our dynamic query tool. This is a powerful tool that allows you to select things quickly within your model. So if I type in 501, scroll down to road and select it, now we can see I've got all the features that are within that road. I've got curbs, road shoulders, traffic lane, and so on. Now I do not want to send all of those to Tekla Structures, as there'll be a lot of bloat. But what I do want is the top level stakeout strings. And we can see I've got 89 of those. Now my road goes on for 3 kilometers. And I know for a fact that our bridge is not 3 kilometers long, so I can actually cut our road strings that we have to send across. And in order to do that, I go to the location tab at the top and add myself a location shape. But before I do that, I need to get a 2-dimensional view rather than this 3D view. For me to get that is very simple. First of all, I want to know what chainage this part here is, where I need the bridge. So I'll go back into my road models, I'll drag and drop my alignment, and now I can see where we are. So from 2920 to 2980 approximately. Now if I right click and view in plan, drag my alignment onto it, and change my presentation rule over to road. It's much easier to see. Scroll up, and here's where our bridge is. So now if I select up here, now if I select on the top right, add location shape, and I'll simply select around this area, press enter. Now once I've finished that polygon, it will cut the string lines within that boundary. Now one final thing, I need to bring across my alignment, as that's going to be the central point for my Bridge Creator tool. So I'll type in 501 again, choose my center line, and make sure that I've got my linear element ticked, like so, and press close, and finish out my task. Now not only can you get this great 2-dimensional view in Quadri, you're able to publish this to DWG as well, for quick and easy drawing production from 3D models. This isn't only just for roads, but your entire federated models you're able to do this with. In order to get the Quadri connector for Tekla Structures, you simply need to go to the Tekla warehouse and download Quadri connector for Tekla Structures. Now if I go over into Tekla, already have part of the abutment and piers modelled in. And if I go to my applications and components on the right, and double click to open the Quadri connector. What this will do is then enable a live API connection between Tekla structures and Quadri, both open on the same desktop at the same time. Now with the tool open, all I need to do is select my task, Road 501 Stringlines to TS. It will get the content from it, and we can see what I've selected here, my linear element, which is my alignment, and then my stakeout string top level, which is all the string lines. I need to choose a base point, and then press Import Quadri Features to bring it all into TS. Now in my case, I'm just doing a simple line import, but you're able to bring across surfaces and solids as well through the Quadri connector. Not to mention, if you don't want to use the connector, you're also able to use IFC, as Quadri has full IFC capabilities ranging from 2.3, 4 and 4.3 as well. Now we can see that it's brought them all across, along with my alignment and changes along the middle. So I can go ahead and move that off my screen and open up the Bridge Creator tool. I'll drag that into view, and we can see that I've already got some components ready made for this. I've got abutments, I've got my decks, and then components for the parapets and all the beams underneath as well. This has been done using the string lines from the road model. So with that string line selected there, we can see that it's got a unique code for where it is relative to the alignment 1.01, and it's called right lane 1. Now if I was to go into my general tab on Bridge Creator and select on the edit for my key sections, we can see all the different names for the string lines that I've got here. So for that string line, for example, you can see it right here, 501_01, 1.01 right lane 1. And it has all the other associated string lines that we need to constrain the cross section to it. So I'll close out of that. Change my view slightly. From here, I'll select Read Alignment, Pick, and then I'll simply drag my selection across and middle mouse button. Now it'll ask me to activate my reference line and my active lines. So for my reference line, I know that I want it to be my alignment. And I'm also going to activate all the associated string lines that I need as well, because they're all used to constrain the cross section. I'll do it like so, press OK, I'll save it, and then press Create. And in doing so, we can see that it's created that first abutment constrained to the string lines. Now I'll go ahead and do the same thing for everything else. It'll be the same process. So I'll select my new one, Read Alignment, Pick, select all my string lines, choose my active and my reference, like so. Now this might be tedious the first time you do it, however once you've done it once, if you keep the same name for your string lines, when you update it from Quadri into Tekla structures, you'll very quickly be able to update them by simply selecting Create rather than having to select the lines again. I'll speed up this process for your viewing pleasure, so we can get on to the exciting next steps. Now keep in mind that this is only one basic workflow between Quadri and Tekla structures. By the end of the webinar, I'm sure you will have thought of many more use cases that's custom to you, such as creating temporary work scaffolding using ScafPlan, where you've brought your existing situation across from Quadri using the connector, or perhaps creating concrete pours and using Quadri to communicate them effectively. Now that we've done that, we can pass it through into Quadri. We can see we've got the piers, the beams, abutments, parapets, deck, and so on. And to pass this through into Quadri, it's as simple as using the Quadri connector again. But rather than going onto the Import tab, we go to the Export. And we'll change the selected task that we're using to one that I've already made, O2 Scarfell Pike Bridge, which is the name of this. This is simply just another connector task like we created before. To pass things across, all I need to do is select them like so. We can see that I've got 3,300 objects selected, as I need to make sure that I select the parts and not just the assemblies or components. I have some more options to use as well. So if I open up my Attributes tab, I can select what attributes I'd like to pass across from Tekla structures into Quadri. Now if you want to pass across everything, you're more than welcome to do so. But I'm going to pass across just a few, such as the class attribute, the material, the name, the weight and the volume, and then that's it. Make sure that you've still got a base point selected, and then you've got two more options to the right. The first being triangulate geometry. This will simplify the geometry that you have in Tekla structures, as a lot of the time it's quite complex, and when you have very small parts, they may not necessarily function well in Quadri. So this option can help with that. It's especially useful for things like scaffolding. At the bottom, we have show conversion rules. Now I'm going to tick this so you can see the process that it goes through when it goes from Tekla to Quadri. Now I'll export selected Tekla structures objects. And what it's doing in this process is picking up all the objects that we've got here, changing them into Quadri geometry, passing all the attributes through, and then in a second we'll see the conversion rules come up, like so. Now you can imagine this is the brain of the whole operation, as this is the middleman between Tekla structures and Quadri. So at the top here we can see some examples. On the left hand side is the source, in this case Tekla structures. I've got my tagged value list, which is simply just the list of attributes, and then my sub-attribute name. What this means is that if the Tekla structure's part name is abutment, it'll turn into a bridge part. It'll do the same for deck, pier, and parapet. If we scroll down, we can see some different variants. For example, if the name is bearing, it will change to a bridge bearing, as well as urban art to sculpture, tower to tower, vehicle barrier to traffic barrier, and so on. These are entirely customizable to your standards and to fit your needs. Now, if I select the third radial at the top and choose any of my rules, this is the attribute mapping. So if I scroll through this, we can see that I've already got some populated. So here what this is doing is it's having a look at the attributes on each part and it's mapping it to an attribute in Quadri. So we know that I selected class underscore ATTR in Tekla structures and pass that attribute through. What that's going to do is pass it down to the class sub-attribute within Quadri. Now these are all customizable to your standards once again. I've done the same with the material, name, and so on. And if I scroll down further, we can see that I can also change the name of my actual feature within Quadri. So currently this isn't particularly useful as what it is, so I'll change it to name. That means it's going to take the attribute name from the Tekla structures part and make it the feature name within Quadri. Now if I press OK on that, let's see how it turns out. It will pass the geometry through in chunks of 200. Now that all the geometry is passed through, I'll move my connector out of the way. I'll scroll down to where my task is, right here, right click, and then view in 3D to see what's been brought across. We can see that some of the geometry is slightly changed. This might be due to some triangulation issues with the passover, but that can simply be sorted by selecting the triangulate geometry option in Tekla structures. If I go ahead and select one of my components in this, such as the deck, first of all, we saw that the name has passed across, and then in the properties in the bottom left, if I scroll down, we can see the material, the class, and the name, so it's all brought across as expected. Now considering that everything is object-based in Quadri, it means that we have full customization of the render handler as well. So if I change my presentation rule from default to something that uses the Tekla class attribute to color, like so, we can see that rather than rendering by material, we're now rendering by the class attribute. So if I was to select on my deck, we know it's got a class attribute of 11, and in my presentation rules on the right, we can see that renders it as a familiar Tekla color blue. It's done the same with everything with a class attribute there. Now if I was to open up my federated model view again, like I had before, simply double click, it will automatically update and it will have that new bridge that I've just created in there. And we can see it fits in there perfectly. Now what we'll do is something that road designers do best, and that's change things last minute. So what I'll go ahead and do is I'll change one of my lanes width from 3.5 meters to 4. That'll completely mess everything up, so it has to be redone. But have no fear, because we can pass the strings through to TS, use the bridge creator again quickly, and change the design fast. So if I go to my road task, where I've created it in NovaPoint, go to my design tab at the top, and go to my road surfaces. I'll drag this across, and we'll go to 2920, here it is, and I'll change that width to 4 meters, and I'll just use 3000 since it's already there. I'll change that to 4 meters as well. So I'll add on half a meter along where that bridge section is. I'll hit apply, OK, and then finish. Now in doing that, it will change all of the string lines, surfaces, and solids in my road model, which can be used to pass out to Tekla structures or other authoring tools if any other changes need to be done. There we go. Now if I go ahead and zoom into my area of interest, we can now see that the curb is in fact behind the safety barriers here. And it's just on the road shoulder, which isn't exactly ideal. So what we'll do is we'll pass those road strings across again and change it in the Bridge Creator tool. Now, I don't actually need to do anything in Quadri at all in order to do this change, as my tasks would have automatically updated. So all I'll do is minimize that. I'll go into TS, I'll drag my connector back across, go to the Import tab, update my tasks, go to my road strings, like so. And all I need to do is use the Import and Replace Quadri Features function. So if I just select everything in my view here, it'll automatically know that I just mean all the lines, and I'll press Import and Replace Quadri Features. This will change all the string lines for my new one, along with the alignment if that's changed as well. However, in our case, it hasn't. Again, not only can you do this with string lines, but you can also do it with surfaces and solids that you may be using as reference geometry for any of your other designs. Now that that's done, let's move the connector out of the way and zoom in to have a look. Now we can see that my strings have changed. So if I select on this, we can see that my left shoulder is now behind the parapets where we want it. So looking on the other side, we can see that the front of it is constrained by those two. Now, this is simple to change because we used the Import and Replace function. So all we need to do now is go back to the Bridge Creator tool, open it up, I'll drag my selection across here, I'll go to my deck and update that, press Create, and then yes. And it will update the deck with the new geometry. Like so. We can see that it's now constrained it by those two lines as we want. And if we go to the other side of the abutments, we can see that these both need changing as well. And we can see that this is a -1b on there, and that's -1. Let's go into here and change the appropriate ones. So I'll simply select and then press create. Now that's moved. Go to our next one. Create. Perfect. And then on the other side, just remove these. Select and create. Now you'll notice that I'm not having to pick all of the string lines again. This is because it's kept the references from when I did it previously and saved it, saving me quite a lot of time in doing this process. Now in my case, I'm using the Bridge Creator tool, but you could be using Grasshopper as well to make it even more of a swift process for yourselves. And don't forget that Quadri also connects with Grasshopper, so you can directly manipulate the geometry and string lines from that. Now I'll close out of that, and now my bridge is updated with that new design information. And to pass it back across again, all I need to do is select my task, go to export, drag everything I've got. This time I'm not going to show conversion rules as I've already set them up, but I will in fact triangulate my geometry to fix the issues that I had on the side. Now export selected Tekla structures objects to finish it out. Now the export's complete, let's go back into Quadri to see how it looks. Close out my design. Let's go ahead and view my road. Here we are. And then I'll drag and drop my new bridge onto it. Like so. Zoom into the area. And now we can see they're exactly where I want. Rather than being on the road shoulder, they're back on the pavement where they belong. Now this is just one example of a workflow that you could do between Quadri and Tekla structures. However, there's so much more power that it can offer to your workflows. Perhaps not just in your bridge design team, but any temporary works, any civil infrastructure disciplines that you have, such as road, rail, water and sewer, and so on. It's important to remember that Quadri is so much more than a simple model federating platform. It can be used throughout the full project lifecycle, from early preliminary design through to design, scheduling, construction, and operation phases. All it takes is some inputs from the designers, the contractors, and then as-builts to allow this process to succeed. The connectors allow you to take native design files from Revit, Civil 3D, Bentley Open Roads, Tekla structures, and so on. This allows interdisciplinary designers not only to federate their models for their viewing pleasure, but also interrogate, export, and push and pull between the two. So for example, if you had a Civil 3D road surface design, you'd be able to push it through into Tekla structures to assist with bridge design. Or if you've got a Bentley Open Roads alignment, you're able to push that back through into Civil 3D, or use our own tool NovaPoint for it. Any changes that you have in these native design forms are able to be easily updated just using the connector like I showed you with Tekla structures. When you've got everything in Quadri, it's very simple to export things to Trimble Connect, which acts as an interface to the outside world. In there you can store all the files that you've exported from Quadri to push it downstream, to do tasks such as 4D sequence modeling in a software of your choice. Provide an asset model handover, as your Quadri model will have your full federated design models, including any volumes that they have and attributes. Machine control. All your surface and polyline design from your road design tools can be pushed directly out to machine control formats. Don't forget setting out surveying. You're able to push things out to Trimble Connect for Trimble Access or augmented reality solutions at Trimble Connect AR or the HoloLens and so on. Here's an example of how Quadri and Trimble Connect is being used here and now in the UK. This is an example from MJ Church, an earthworks contractor. Here on the screen we can see Trimble Connect for Web Open that has a full federated model. Now this was pushed straight from Quadri into Trimble Connect. It's made from a combination of different file formats from Trimble Business Center, Civil 3D, surveys, and so on. However, in your cases, you may be using all kinds of file formats and even the Quadri connectors. Using Trimble Connect for Web allows you to access the model anytime, anywhere, as you're able to get it through a laptop, phone, or a tablet, for example. You've got great capabilities for annotation, markup, and measuring, like he's showing just here. Here's an example of Sight Vision being used, where we've brought the Quadri model through Trimble Connect and into the Sight Vision unit, geolocating the model to show exactly what will be built, greatly improving stakeholder communication and make the clients happy. You're also able to interrogate straight from the unit as well. Now this is just one example. Feel free to let your imagination run loose and think about the possibilities you can use this for. Thank you all very much for watching, and if you've got any questions, I'm happy to answer them for you.